Hey, welcome to the next video of our FlatRedBall top-down 2D twin stick shooter video tutorial series. And last time, if you recall, we got our character, we replaced the art with a spaceship, but now we have to finally get our hands dirty with the code and make it rotate correctly. So I'll show you what I mean real quick. Here's how we left it. Character does not rotate in the direction they're traveling. We want to change that. So I'm going to stop the game and take a look way over in the top left corner here for this little purple Visual Studio button. We're going to click that. And hopefully, if you installed Visual Studio Community, like I mentioned at the beginning, it will open the project in Visual Studio. Now, you can use a different IDE or whatever text editor you want, but we're going to be using Visual Studio. So if you want to make the easiest job following along, just use Visual Studio Community 2022. And so when we open a class, when we open a script in FlatRedBall, actually, I don't know that yours will have the player open by default, so I'm going to close that. Maybe this is more like what you got when you clicked that button. So what we're trying to do is modify the code of the player entity here. So if you notice in the Explorer window here, there is a code folder, and inside of that there's three .cs files for .c#, and these all combined equal the functionality of the player. The two that say generated are generated by the game engine. They're generated by FlatRedBall, and you just want to remember that you never ever in FlatRedBall want to manually change the generated code, because as soon as you basically do anything, it will overwrite whatever your changes were when it regenerates. So the part that we are allowed to customize and edit is this regular player.cs that doesn't have a generated kind of suffix. So keep that in mind. There's a lot of generated code in FlatRedBall, and just if you notice you've accidentally opened the generated version, stop and then find the regular one. Okay, so you could double click this and it'll open with whatever text editor you have associated with .cs stuff, but it may not open like your actual project in the way that it does if you click the Visual Studio button. But when I open this, I have nothing open. So you could either find the player over in this Solution Explorer. I have no idea what the default Visual Studio window arrangement is, so sorry if it's kind of crazy. But you can see there's a bunch of stuff in here. It's hard to find. So I'm going to hit Control, comma, and it brings up the little handy search thing. And I'm going to type player.cs, and you can see we don't want to click generated. We want to click the regular player.cs. Okay, so I want to kind of walk through how code files are typically organized in FlatRedBall. We have our player class here, right? And it looks pretty empty, and that's because a lot of the functionality is in the generated code. But we can write our own custom behavior in these various custom methods, right? So initialize is what's gonna initialize when we first load the entity or whatever, and then activity is going to be executed every frame. So any type of update related functionality needs to go in here. And since we want our character to be rotating in the direction that they're traveling constantly, not just once at the beginning of the game, we need to write that code inside of the custom activity. All right. And so what we're going to do to accomplish this, we're going to kind of like start uh, with an effort that isn't fully developed, and then talk about what's wrong with it, and then finish it from there. So we're going to look at the velocity of our player, and if the velocity dot length, which is like, it's like the magnitude or whatever, it's like if we're moving at all, this number will be greater than like 0. But let's put in something small, just to kind of give us a little bit of like a, I guess, like a dead zone or something. So if the velocity is greater than 0.1, and we have to add that f here just because this is like a float, we want to do something. Well, what do we want to do? We want to rotate the player. Now, I want to warn you all that I am not the most mathematically inclined individual. This is why I got into game design and not game programming. But bear with me and we can try to talk through this. So, and I will say this, if you want any clarification, remember that really awesome community that I talked about with FlatRedBall is like one of the whole perks of using it. I encourage you to ask about it here and be like, hey, that dumb guy on YouTube didn't do a good job explaining this. So I've turned to Discord to ask what it means. All right. So if our velocity is greater than this small amount, we want to rotate the player, and we want to rotate them on the Z axis. So we want to use rotation Z. And I guess the best way to explain this is like, if you were to imagine that the thing that you want to rotate has been skewered by a spear, like that's this, which axis is doing the skewering. So if I skewer it on the Z axis, and then rotate that skewer, the spaceship is going to turn the way I want. I don't know, that's an awkward explanation, but I don't have the right visual aids to do it better. So just go with me here. It's rotation Z is what we want. And so we want to set the rotation Z to be based on the direction that the player's moving. So in this kind of like 2D FlatRedBall game, we can actually look at the angle in radians of the velocity vector, and that is going to kind of tell us what direction our avatar is moving, our player is moving. So this is complaining because we need to say that it's a float, basically. So let's just like explicitly cast this as a float for now and save it. And I guess I should point out, you could actually run the game this way. And this is like what we would do if we want to do some like real debugging, because you can put in breakpoints and stuff like that. But right now we're kind of like living in FlatRedBall editor world. So I'm just going to go stick with that. And let's wait for it to run. And hopefully I didn't break anything. And so, okay, we're in business. But if you notice, it's actually like not quite right. So if I move left, I'm pointed down. If I move down, I'm pointed right. If I move right, I'm pointed up. And it's all kind of just off by 90 degrees. And I want to point out one more thing. If I just stop the game and run it and I don't press anything, let's take a look. Well, that doesn't make sense. Never mind. But anyway, yeah, it's like almost working, but it's all like offset. So let's try to explain that. In order to explain that, we're going to look at the FlatRedBall Rotation Z documentation page. And specifically, we want to take a look at this diagram, which is showing us a circle and like basically the radian increments of a 360-degree circle, right? So this 0, if we go back to our code and we like mouse over angle, you can see it says like 0 is to the right. So um, that's that's lining up with what we're seeing on this diagram, right? 0 would be like, if we think of these as directions, 0 is to the right, and like up would be 1/2 pi or pi over 2, right? And then left is pi, and then down is 1.5 pi or whatever. And then like 2 pi would be like the full 360-degree circle, right? So if we think about it, by default, like our angle thing is like 0 is to the right. But if we go back and revisit our artwork, you can see that our ship is pointed up. It's not pointed to the right. And so that's going to explain that like 90-degree offset that we have. So we essentially need to offset all of our rotation that we're doing in code here by 90 degrees, or since we're using radians, it's like this direction. So it's pi over 2 or 1/2 pi. If we were to offset all of the rotations by that, it should be lined up correctly. And so that's what we're going to do. So we're going to go in here and we're just going to subtract by math f dot pi divided by 2. And let's save that and see what happens. So go back to FlatRedBall, run the game. And now I'm actually moving in the direction, or I'm rotating towards the direction that I'm moving. So that worked. Okay. So I know that was like our first foray into code, and we like immediately started with rotation, which is like what I think is one of the hardest things, just because like I said, I'm bad at math. But at least now you know a handy way to deal with it in this kind of like 2D context in FlatRedBall. So we're going to stop this video here, and in the next video, we'll start thinking about, I guess, maybe environment art, but we'll see. All right, I'll catch you there.